Welcome to OneDayApp, where I'll teach you to go from web to app developer in just one day using the Phonegap framework. By the end of this series, you'll have a real application that stores notes by location for users that you could deploy to the App Store of your choice. This is Chapter 3, using SQLite and qUnit to build persistent app storage. We'll start with SQLite creating your database and walking through the basic CRUD operations to create, read, update, and delete the note data in your application. We'll also cover how you can version your database from release to release and upgrade your user data. For all this, we'll be using the qUnit browser-based script testing framework to validate the data layer of our application. At the end of this chapter, you'll have a suite of passing test cases that validate handling our location and note storage, as well as calculating the distance between locations and finding the nearest notes to the user's current location. The initDB function will take just one argument, a callback that we'll use to validate that there were no exceptions. After the OK assert is called, we'll tell the test execution to start again. The first command will be to open the database function. The open database command takes a short database name, a version number, which we'll get to when we discuss versioning, a longer description, and a max size that we'll define. So far, we've been working on the basic CRUD operations, but the heart of this application is the ability to find notes close to your current location. If I'm at this first location here in Sammamish, Washington, and I have a note located in Mukilteo, Washington, Google will tell me that the distance is 25.3 miles as the crow flies. However, if you want more accuracy, then you'll need to use the Haversine formula. This equation takes latitude and longitude coordinates and calculates the shortest distance between them, taking into account the curvature. We'll order the results by this rough distance calculation and limit the results to the top 20. This will help ensure that we're never dealing with hundreds of results with what happens next with our expensive math calculations. We instantiate our array and loop through the results. For each result, we'll extract the row. We'll calculate a more precise distance, and we'll add it to our array. Next, we'll call sort. You can simply click to expand each of the objects to see a value and check out what's going on as your test is executing.